Why do we use an activation function in a neural network? Let's understand this with a simple example. Think of a neuron like a smart switch or a decision gate. It receives input, apply weights and compute a value. But without an activation function, this input remain linear. And here is the key limitation. A linear model, no matter how deep you train, cannot learn a complex pattern because stacking multiple linear layers still result into a single linear transformation. So the network failed to capture curve, decision boundary or the non-linear relationship found in a real-world data. This is where activation function become essential. They introduce non-linearity, allowing the network to model complex behavior and real-world pattern. For example, ReLU decide whether a signal should pass or block by removing a negative weight. Sigmoid convert output into the probability between 0 and 1. In simple terms, activation function helps neuron decide how much information should move forward. Without activation function, deep neural network reduced to simple linear math. And a real world problem are never linear. That's why activation function are the backbone of deep learning. Let's discuss about various type of activation function that are used in a neural network. Let's start with the sigmoid. Sigmoid convert any input into a value between 0 and 1. So it works like a probability. For example, in spam detection, an output of 0.9 means 90% chance of spam. That's why sigmoid is used in a binary class classification problem. But sigmoid has a drawback. It causes vanishing gradient which result into slow learning of neural network. Next is tanh. Tanh is similar to sigmoid but its output ranges from -1 to +1, making it zero-centered. This helps the model learn better than sigmoid, especially in a task like time series or RNN. However, tanh suffer from the vanishing gradient problem. Finally is a softmax. Softmax is used for multi-class classification. It converts output into a probability that add up to 1. For example, in image classification, it may say 70% cat, 20% dog and 10% cat. Its strength is a clear probability interpretation, but it doesn't work for a multi-label problem. In short, sigmoid for binary output, tanh for balanced signal and softmax for multi-class prediction. ReLU is the most commonly used function in deep learning. Its rule is simple: when the input is negative, the output becomes 0, and when the input is positive, the output remains same. This simplicity makes ReLU extremely effective in a deep neural network. ReLU allows positive value to pass through without compression, which help maintain strong gradient during training. Because of this, neural network learn faster and perform better, especially in a deep model like CNN. For example, in image recognition, ReLU block irrelevant feature while allowing important pattern like age and shape to move forward. However, ReLU has one major limitation called as dead neuron problem. If a neuron repeatedly receives the negative input, it may always result into the 0 and stop upgrading their gradient during training. To overcome this, leaky ReLU was introduced. Instead of blocking negative value completely, it allows a small negative output which keep gradient flowing and reduce the risk of dead neuron. An advanced version is parameterized ReLU, where the negative slope is not fixed but learned during training, giving the model more flexibility. Another variant is ELU. It smooths negative value using an exponential curve. This improves training stability and often helps model coverage faster. In practice, ReLU is the default choice while its variants are used when better stability or performance is required. Together they form the backbone of deep learning.